So in this part of the experiment, we're going to be using the salts and we're going to put them in. We're going to see how the salts either absorb or release energy when they're dissolving. So, of course, I'm tearing this and I'm going to, again, use those 40 mils of water. I'm going to pour it in. Not too fast. So now we're going to weigh out the solids so we can see what happens with these reactions. These solids are hygroscopic. It means that they do absorb water, so you might have to really chop them up a bit. Set this in here. I'm going to tear it. I'm going to weigh out my 5. I think that's going to be about 5. And they don't want to have a dirty balance. Oh, about twice as much as that. So you can kind of see about how much. A little more. Definitely want to have my temperature probe, right? So I want to know the temperature of my water beforehand. I'll put my probe in my water. Make sure I've got the right temperature. See what happens when I put my salt in. I'm going to stir it. You should see something cool happening. Make sure it's all dissolved. Pretty sure it all is. I think this is really, really neat. Okay. Can you see it's all dissolved? Can you see that it's... Put this in, tear it. Make sure that it's okay. I'll pull it out the side here. How much that is. Oh, I'm going to need a good bit more. So this is anhydrous. I'm having to kind of scrape some of it out. That's fine. Let's see how that. Still have a ways to go. Oh, that's close. That's fine. Okay, so I'm rinsing off the temperature probe because I don't want any of that solution to contaminate this solution. So now we're going to do it with this one. Set this off to the side. Here, first I got to get the temperature of the water. Give it just a second. So I'm going to take it out for a second because I don't want to, this is very, very powdery. I don't want to make a mess with it. So you'll notice if I just pour it in, I've still got the policeman part. Because if I wait it out, then it's going to be part of the calculation. Now I'm going to put this back in here. Let's see how that temperature is changing. Can you see it's already going up? Dissolving it in. I think it's pretty powdery. Make sure it's well dissolved. I'm not positive it's all the way dissolved. Second here.
This section of the lab involved dissolving 2 different salts. You remember one caused the temperature of the water to go down and one caused the temperature of the water to go up. You record the mass of the salt and the mass of the water. The reason you need both of them is because of the way that we calculate the Q for the solution. Now this represents the word dissolution, and the reason why we're even using this is because Q is amount of heat lost or gained when a salt dissolves. And so we just take this SOLN, and it comes from the DISSSOLN. It comes from this word right here. You can have all different kinds of Q's and H's, and sometimes the subscripts are specific as to what's going on. So the reason that we have the 2 masses here is that when we calculate the Q of solution, we need to use the entire mass of the solution, not just a portion of it. So when we get to filling out our Q of solution right here, we're actually going to use the mass of the salt plus the water. It's the total mass. Now, the C value we're going to use is the C of water, which was in the last table, part A. And then we're using the change of temperature, and again, this is a value from the water. Pay attention to your change of temperatures. One of them will be negative. Make sure that you don't drop it. Also, the change of temperature is what's going to be helping you figure out your sig figs. There's a note you might want to pay attention to for this section right here. If you don't keep all the numbers in your calculator for each one of these steps, you can end up with a rounding error. To prevent the rounding error, and just for this row, it doesn't cause an issue for the other rows, but for this row, you want to make sure that your numbers goes to the ones place. Don't round them. You can keep up with the numbers. So let's say that the number was 1785. And let's say that you figured out that it needed 2 sig figs. You can do this with a number to remind you as you go through the problem that it only has 2 sig figs. But you need to keep extra places past that sig figs to prevent rounding errors. As before, when you go from the cube solution to the negative cube solution, it's going to be just changing that sign. So if one of them is negative, then it'll switch to positive, and if one of them is positive, it will switch to negative. It's just flipping the sign. Now, this section right here, it says, it has a special note. This is measured per gram of salt only. Yes, you did both of them here, and in here you only did per salt. It does seem confusing. Just go with it here. You already got the Q value from up here. That's where you have gotten your Q value. And remember that the unit of your Q is in joules. All we wanted to do is divide by your mass of your salt, which is up here. You can add up the molar mass of the salt because you have its formula here as well as here. And then last but not least, you're going to take whatever number you had here, you're going to put it here. And the unit it's going to be coming over with is a joule per a gram. You remember because that's what this unit is. And you're going to be changing your joule to a kilojoule. And then you're also going to be changing your gram to a mole. You want your gram to be opposite. That will give you Those two cancel, and these two cancel, so that your final unit is kilojoules per mole. And remember that this term right here came from the molar mass of the salt, the grams per mole.